Hello, this is Dr. Mears. Today we are going to be going over the manipulation of probability rules. As you can see up on top here, we have symbols, remembering that this is the and, that's or, and that is given. We also have the rule of mutually exclusive, where events cannot happen at the same time. So probability of A and B equals 0. So if you're flipping one coin, a heads and a tails cannot happen at the same time. So the probability of a heads and tails would be 0. For events that are mutually exclusive, to find one or the other or both, we can add them together. However, if they're not mutually exclusive, meaning that you can actually have events happen at the same time. In order to find one or the other or both, we're going to have to add those probabilities and then deduct out the probability of and. And the reasoning behind that is if we draw this Venn diagram, we have the probability of A and the probability of B. So for mutually exclusive, this is what the Venn diagram looks like, A and B. There's no overlap. But here, for not mutually exclusive, what's going to happen is you're going to have the probability of A, which is this entire circle, and then you're going to have the probability of B, which is this one. So this overlap will be counted twice if we just added these two circles together. So we have to take out minus one of the middle parts that you added twice. So that's why that rule happens. Then you have conditional probability, where you have the probability of A given B, and so this denominator really relies on the given part. So we have to find the probability of B is the new denominator, and then the numerator is A and B happening at both A and B. And then lastly, we have independent events. So A and B, you can take the probability of A and multiply it by the probability of B for independent events. All right, so let's go through and utilize these rules and manipulate them. For this first question here, we have events A and B. The probabilities of A is 4 out of 13, and the probability of event B is 5 out of 13. I'm sorry that if you can't see it here, I'll just rewrite it. It's very small on camera. So probability of B, that's not even good. Let me write it up here. Probability of A is going to be 4 out of 13. Probability of B is going to be 5 out of 13. So that's what these say right here. All right. So part A, if events A and B are mutually exclusive, we have to write down the probability of A and B. So the key words here are mutually exclusive. So if you look up at the mutually exclusive, I just start it right here, rule, we see to find the probability of A and B, it can't happen. So the probability is going to be 0. So the answer to this question is going to be 0. So that's what you would write down. Please do not put the slash through it because that means empty set. Just write the number 0. So 0 equals the probability of A and B. And that's all because they are mutually exclusive. Getting tired because I'm writing it down. So this equals 0. There you go. Okay, the next one, if events A and B are independent, find the probability of A and B. So what we have to do is let's look at our independent rule. So we're right here. For events that are independent, probability of A and B, we multiply them together. So we have those two probabilities, so let's multiply them. 4 out of 13 times 5 out of 13. Multiply numerators, 4 times 5, which is 20. Multiply denominator, 13 times 13 is 169. If you would like to reduce that down to a decimal, that's absolutely fine. It's 0.118. Just divide 20 divided by 169. All right, next, if the probability of A or B is 7 out of 7 divided by 13, or 7 out of 13, probability A or B, 7 over 13. I just rewrote it for you. Find the value of A and B. Note, assume events are not mutually exclusive. So because these events are not mutually exclusive, we're going to be using this rule right here. So they gave us the probability of A or B. They gave us this. They gave us the probability of A. They gave us the probability of B. So now we just have to find the missing A and B probability. So the rule that you're going to be using, and I'm going to do this out, probability of A or the probability of B equals the probability of A plus the probability of B minus the probability of A and B. So let's just fill in what they gave us. The probability of A or B is 7 out of 13. The probability of A is 4 out of 13. The probability of B is 5 out of 13. minus, this is a minus, and that's what's missing, so I'm going to just make that x because that's what they want you to find. So now you can simply change this into decimals if you want. I am going to do the fraction just to show you some fraction work. Here, these have the same denominator, so we can add them. We keep the denominator, that's why we need the same denominator, and we add the numerator, so that's 9 minus x. We need to solve for x, so we're going to subtract 9/13 from both sides. That cancels out. 7/13 minus 9/13, again, keep that common denominator, equals 2/13. And that is equals negative x. So this is really a negative 1 in front. So I'm going to divide both sides by negative 1. So x is going to be 2/13. And that does equal the probability of A and B. So what we did is we used this rule. There you go. We used this rule. We substituted our information in, and we actually solved for the probability of A and B, which is going to be 2/13. Okay, the second one. Let the probability of A be 0.5, the probability of B be 0.6, and A or B is 0.8. So I'll rewrite it. Probability of A is 0.5, probability of B is 0.6, probability of A or B is 0.8. And then I'm just going to put a little line right here. Okay. So let's go through and see what they want to find. Here it says find the probability of A and B. So probability of A and B, let's use the independent rule. Probability of A and B equals the probability of A times the probability of B. So 0.5 times 0.6 is 0.3. So that's that answer. Part B, find the probability of A given B. So what we have to look for, and I'm going to do this here, probability of A given B. So now the denominator is going to be the probability of B. That's my denominator. So let's look. Denominator, 0.6. So remember, what's given is now our new denominator. Our numerator is going to have to be, and if we look up here, here's our denominator. That's B. Our numerator is the probability of A and B. And so I think I just recall that I found that. I found that here. A and B is 0.3. So that's the numerator. So we have 0.3 divided by 0.6, and that comes out to be 0.5. And so that's our probability of A given B. It's just A and B, which is this, we've just found it, divided by B, which was this here. They gave that to us. All right, part C, decide whether A and B are independent events. Give a reason for your answer. So this is what we're going to do. So if they're independent events, then that means that the probability of A and the probability of B equals the probability of A times the probability of B. So probability of A and B, 0.3. We got that by multiplying 0.5 times 0.6, which 0.3 equals 0.3. However, let's also see if we can prove it using the OR rule. So we have this information. So what I'm going to do is I'm actually going to write this down. I'm going to write this rule down, and I'm going to see if this also comes out to be 0.3. I'm going to do that on the back of my paper. So I'm going to transfer this information. So it said the probability of A is 0.5. The probability of B is 0.6, and the probability of A or B is 0.8. Now, I found the probability of A and B, if they are independent, it would be 0.5 times 0.6, which is 0.3. Okay, so this is what we're looking to get. So I'm going to be using probability of A or B equals the probability of A plus the probability of B minus the probability of A. So let's substitute these numbers in and see if I get 0.3 using this one. So I'm just manipulating these formulas to see if everything works. So A or B, so that's 0.8 equals the probability of A, which is 0.5, plus the probability of B, which is 0.6, minus, I don't know what this is. I'm looking for this to be equal to this if they are independent. So let's see what happens. So 0.8 equals 0.5 plus 0.6 is 0.11 minus x, minus 0.11 minus 0.11. 0.8 minus 0.11 is negative 0.3, which equals negative x. That is a 1, so dividing by 1, we get 0.3. Hey, this does match up with this right here, so I also proved it another way by using this rule right here, manipulating it So 0.3 equals 0.3, which means they are independent. Yay, that was pretty cool as well. Okay, so this has been the manipulation of rules. It was about 10 minutes. I thought it was going to take 7. Sorry, 3 more minutes over. Hopefully this helped, and ask me questions. Thanks. Bye.